Okay, good morning. And today, first we'll start with the estimation of the flood hydrograph because when you develop a model in HECRAS, you need some kind of flood to route that flood. Then how to get that flood? Because most of the time we work in the catchment which are not having any rain gauge stations or any proper gauging sites. And then in that case, how to establish? Because if you have the lot of data, you can go with the extreme value analysis like Gumball. You can use that and get the flood frequency. But if you don't have any data, the catchment is totally ungauged. There are no rain gauge stations, no rainfall stations. In that case, the CWC has provided some approach using a synthetic unit hydrograph. That approach we can use and derive the flood. So they have divided. So I think Madam will start. Okay.
Good morning, everyone. As Sir has told, when a particular area is not having any gauge data, in that case, this hydrometeorological approach is used. So basically, there are 26 flood protection. 26. India has been divided into 26 hydrometeorologically homogeneous subzones, and a number of flood estimation reports were prepared. These reports are joint efforts of CWC, that is Central Water Commission, Indian Meteorological Department, Research Design and Standard Organization, and Ministry of Surface Transport. So, in these reports, uh, a procedure for developing unit hydrograph and development of flood hydrograph from that unit hydrograph has been given for 25, 50, and 100-year return period flood. These are the list of the published report till 1994. You can see the names of the reports here, like Western Himalayas. So looking at the name, we can have an idea that which report is to be referred for which region. Moreover, this is just this cover page of that report. In this part 1, that is the introduction chapter, there is information about which region or which areas are covered in that particular manual. देन जनरल डिस्क्रिप्शन एंड सब जोन एक्सेट्रा, मतलब उसमें जो सॉइल प्रॉपर्टीज है, व्हाट काइंड ऑफ स्ट्राटा इज अवेलेबल, दैट ऑल थिंग्स आर आल्सो कवर्ड इन वेरियस चैप्टर्स ऑफ दिस रिपोर्ट. A dedicated chapter for development of synthetic unit hydrograph and flood hydrograph is also given, where we can arrive at design flood for that particular region using hydrometeorological approach. So the first part is catchment area delineation. That sir will explain in his HMS lecture how to delineate a catchment and extract these physiographic parameters. The parameters which we require for this exercise is area, that is the area of the catchment, this catchment area. Then the longest flow path. Longest flow path means from the remotemost point of the catchment till till the point we have this length of the catchment. Then centroidal length, that is to this gauging point, na sir? To this
From the
gauging.
centers, if you take the catchment and take the centroid of that catchment, centroid means that the CG matches that point to the outlet point. That is
Outlet
the
point.
centroid distance.
CG to outlet point is the centroidal length and slope of the catchment. So using these parameters, we have to derive a unit hydrograph.
So just
So
I will
basically,
intervene. So this part I will cover in the Hague HMS. So how to derive. Previously, if you don't have any DM, we used to use the topo sheets, and from the topo sheet we have to identify the reach, and from that reach we used to delineate the catchment. Now this process can be automated in the Hague HMS software, and we get these parameters. That length, first is the area of the catchment, then the total length, longest flow path length, centroidal length, and the slope which are required. So that process I will explain in detail. I will also give the hands-on demo of one of the studies we have done. So we'll be taking the DM for that studies, and I will show you how to estimate that. Okay. Now, based on this, let's assume that we know this parameter right now. That is all the four parameters, and then she will now explain the other
unit
part.
hydrograph. So since this is a hydrometeorological approach, what it is given here, we have to first find out these parameters. These are actually the points on these hydrograph. The first and last point except these 2 points, these 5 points can be derived by using these equations. So we can see QP that depends on L and S, that means length of the catchment and slope of the catchment. So in by using these formulas will be different for different flood protection manuals or different zones. So in this western coast region, QP depends on L and S, that is length of the catchment and slope of the catchment. So we'll be getting discharge per discharge in meter cube per second per square kilometer. From this QP we can find capital QP, that means discharge for that particular catchment, QP into small a, QP into A. Depending on this QP we can find out TP, that is the time to peak. We can see here this is time to peak. So we have got this point x value of this point TP. TP depends on QP. Then W50, W75, WR50 and WR75. These are the 4 points. These 4 points located on this hydrograph. W50 and WR50 are the points on hydrograph corresponding to 50% of the peak discharge. Similarly, W75 and WR75 correspond to 75% of the peak discharge. All these parameters depends on QP, small QP. So we'll be able to get these 4 points. Then base width TB. This is the base width of the hydrograph that depends on small TP. So we are getting this parameter also. TM, TP plus TR by 2. TR is unit duration. It is always 1. So we can see here TP plus this unit duration by 2. That means we will get this value TM. Okay. So in this way we are able to derive a unit hydrograph, draw a unit hydrograph. So these are workout for one particular catchment. These are the parameters, and these 5 points which are located on the hydrograph that are to be smoothened to get a smooth hydrograph. We have to just insert additional points, but care should be taken that these nodal points, these 5 points should not change. Okay. Then design storm duration, it is 1.1 times the time to peak, that is TP. Now we have to estimate point rainfall and aerial rainfall for this design storm duration. So in this manual there are different plates and figures given for 50, 25, 50 and 100-year return period flood. So if we have to calculate for example 50-year return period, so the plates are given for 25, 50 and 100-year. We have to change that rainfall according to our design storm duration. For that we have to use the plates. So first is to find out the point rainfall. So this is plate number 9 for 50-year return period. We have to locate our area. This is the complete figure. We have to locate our area by seeing this lat long in this figure. So we'll be getting one point rainfall. Where our catchment, where our study area lies, we'll be getting a point rainfall. Then apply the conversion factor. So for our design storm duration, say for example it is 4 hours, we can read it from here or we can find out from this graph. So we'll get one conversion factor. We'll multiply that point rainfall by this conversion factor. So that way our 50-year point rainfall for 25 hours will be converted to TD or duration. That means for our design storm duration, that rainfall will get converted. So we'll convert this 50-year 24-hour point rainfall to 50 or TD or means for our design storm duration or rainfall we will get point rainfall. Now this point rainfall is to be converted to aerial rainfall. For that we have to use this annexure. It depends on this area. So for example if our area lies between say 50 and 100 square kilometer and our design storm duration is 4 hours. So we will see the conversion factor will lie between 92 and 88. So we'll have to interpolate and find out for our particular area this conversion factor. Then next step is to distribute this rainfall into 1 hour rainfall, effective rainfall. So for that we have to use these distribution coefficients. So for this our design our TD or rainfall, that is 4 hour design storm duration, we'll get these distribution coefficients. So there is a particular procedure that I will be explaining in Excel sheet. So next step is to apply loss, and then we'll arrive at a flood hydrograph. This procedure, I think it will be more convenient to explain in Excel sheet. So,
Basically, what we are getting some catchment area that we can derive either from the topo sheet or from DM or any source we can get that catchment. If you go to India Varis site, they have the catchment directly for Indus or basin. So directly that shapefile also can be downloaded. Now that much progress has been made because the catchment has been delineated. But suppose your study area don't have any catchment, you have to do it manually. So we will explain either from TopoSheet or from DM. If DM is now globally available, it's a good resolution. DMs are available and they are freely available, so that we can utilize. When we get some DM, we get some properties of the DM. Basic properties what we require is the travel time. Basically, when we learn the hydrology in the colleges or in what we see is that what is the length, what is the shape, basically shape, fun shape or fun shape. That were the two shapes we are always designing because that depends on the your arrival time. So length, why we are more interested in the longest flow path, because that will be the longest time it will take, because to reach the peak that all streams should contribute. So the longest flow path is important, and slope, because slope will determine how the velocities are there. So it's logical basically how these parameters has been derived and what are their use. Length and slope, they define how the time will be taken, what will be the velocity and how much time it will take to arrive. So you can get the if the all streams are contributing at that point, you will get the flood hydrograph that peak. Now that's okay. Then in this procedure, what we are developing is developing a synthetic unit hydrograph. Unit hydrograph once 1 centimeter rainfall, and what will be the output of that 1 centimeter uniformly spread over the area, and then we get the uniform hydrograph, that flood hydrograph. If that 1 centimeter is happening whole the catchment, what will be the outcome of that rainfall to runoff conversion, and then what will be the flood hydrograph? That is a 1 centimeter hydrograph. Basically, unit hydrograph means 1 centimeter rainfall is assumed. Now, in this method, what they have given is first, madam has told you that we have got the isoidal maps. Isoidal maps are there, and based on that maps, what we get is the point rainfall, because your catchment is area, and in this case, you are going to get a point rainfall. So if your catchment and there are 2 or 3 points of contours, you can get 2 or 3 if it's a big enough catchment. If it's a small catchment, you will get 1 or 2 points. So based on your catchment shape and size, you will get 2 or 3 points from this isoidal map, because this area covers. If this map is considered, it covers from the Maharashtra to the Kerala, the total west coast. So your catchment may be small and you may get 1 or 2 points only. So that points you get first, that is for the 24-hour rainfall, because it is clearly mentioned that it is a 24-hour rainfall, 25-year return period flood. So now second thing comes is your storm duration is not going to last for the 24 hours. So it may be have some specific duration, 4 hours, 6 hours, 8 hours, depending on if you do the rainfall analysis. So in this they have given some formula that TPS has been used with some multiplication factor to get the storm duration. Now you have to convert this 24-hour rainfall to the storm duration. So 24, if it is happening 100, for the 6 hours it may be very short. So that rainfall we are getting. Now again it is a point rainfall. Now you have to convert it. Just we have converted to the storm duration. From 24 hour, we have come to the storm duration. 6 hours, 4 hours, any duration. Now that is again point. Now you have to convert it to the aerial. So how to make the aerial distribution? So they have analyzed some in catchments. When they say it's a homogeneous catchment, they have analyzed some hundreds of catchment in that main catchment, and based on that they have find the equivalence. So what is the equivalence? That is how to convert that point rainfall. So they have given some tables. So you are using that coefficients based on their analysis, and that coefficient they have given in the table of one. That coefficient we are using and converting our point rainfall to the aerial. And now how to distribute that aerial rainfall? Suppose it is for storm is for the 6 hours. You have get the 24 rainfall. You have converted to the storm duration. Now you have converted to the aerial distribution. Now you want to get it for your how the every 1 hour, because we get the unit hydrograph per 1 hour rainfall. So if it is happening for 1 hour, that's suppose you are getting 250 rainfall. So 250 will not fall in 250 is falling in 4 hours. So in 1 hour it will not be 250. So there will be a coefficient. So initially what we assume from this analysis, the hydrograph is very steep, so that the flood initial rainfall are very high, and as the storm duration reduces, the rainfall reduces. So based on this conversion, you get the hourly distribution of the rainfall. That hourly distribution you now get, you know the unit hydrograph. You multiply that coordinates rainfall into unit hydrograph for that duration. You get a hydrograph for one. Suppose you have six unit hydrographs, because the storm duration is 6 hours. So you have to lag it by 1 hour. Again multiply it, get that. Lag it by 1 hour for third hour, fourth hour, fifth hour, sixth hour. These are hour, and then you sum it up totally. Then you get this final flood hydrograph. So that is basic procedure what we are doing here. It's a simple, it's a logical process, because they have a lot of data for the homogeneous catchments, similar catchment having the similar rainfall pattern, having the similar soil properties, having infiltration properties. Based on that, they have arrived this formula, and we can directly use our formula. So the madam will now explain the Excel sheet, how to use that Excel sheet, and based on that, we will get the rainfall basically.
Excel sheet याच्यामध्ये